axioms and postulates, there's some similarities and differences between them. Okay, the similar thing is that both are rules that are accepted without proving them. So in both cases, okay, these are relationships that you're going to just assume to be true, and there's not going to be any kind of formal proof to it. That's how they're the same. The way that they're different is that axioms are a little bit more universal, okay, meaning that they apply to a wider range of, so an axiom is going to be true in all different types of math, all science, so it's just a universal truth. Whereas and it's going to be based on logic. Whereas the postulate is going to be a little bit more specific, or limited to a specific field, and not universal to all fields. Okay, and for the postulates that we're going to see, most of the postulates are going to be based on constructions or geometric constructions. Okay, and for both cases, again, it's going to be accepted without formally proving them. Right, some of the other just terminology that you're going to see, a coordinate right here is going to be a real number that corresponds to a point on a number line. And so often, a coordinate is going to have, or will often be represented with a lowercase letter that corresponds to the point. So point A will generally have a coordinate A, point B, coordinate B, and again, most of these will be assigned with an actual number. So if you say the coordinate of point A is 5 and the coordinate for point B is 10, that's just going to be, those are the real numbers that are associated with the points on a number line. A construction is defined as a geometric drawing that uses only a compass and straight edge. Okay, we're not going to do constructions here in this class, but really quickly as far as the definitions go, a compass allows you to draw circles, and a straight edge allows you to draw straight lines. Like I said, we're not really going to emphasize constructions this year. We'll talk about them a little bit, some of the basics of them, but if you see the word construction is a specific type of drawing, and it's one that only uses a compass and straight edge. And then betweenness doesn't really have a definition like that we're going to talk about, but it just has to do with the relationship between points. So if you're saying that point B is between point A and C, it just means that it falls somewhere on the path between, or the path from A to C. The first is going to be what's called the ruler postulate. The ruler postulate states the following, that points on a line can be matched one-to-one with real numbers. So notice the word postulate means that this is just, it's going to be accepted without being proven. Okay, it's relatively specific to this field of geometry. Okay, but what it really means here is that when you're measuring the lengths on a ruler, okay, each number corresponds directly with a single point, or each point corresponds directly with a single number. So if you're looking at this example right here, and you're trying to find the length of AF, you're going to go from point A to point F, and you can see it goes from 0 to 15. And at this point, you're just counting them off. And we'll go through some formulas, relationships for distances. But here, you're just counting them. So that's going to be a total length of 15. Okay, so really quickly, count the remaining two, EF and CF. Find those, the lengths of those segments, please. So for the most part, this is pretty intuitive to you guys. We'll talk about more the formal calculation method for them. But my assumption is that all of you can look at these and see that if we go from E to F, you can either think of this as being E is 11.5, and so you can mathematically find that difference, which is a little bit more of what we're going to do here in a second with a distance formula. Okay, or you can simply count, right? So if you start with 11.5, go here's 1 to 12.5, to 13.5 is 2, 3, and then half more, so 3.5 is what you would be counting if you just use that principle that points correspond 1 to 1. And so what's the distance from C to F going to be? 7 to 15 is a distance of 8. Okay? Now, these are things that you do intuitively. You're counting them. Okay, but there's also a formula relationship that you can use for this, and that is using this concept of distance and a distance formula. Okay, so again, by definition, the distance is the absolute value of the difference between coordinates. And so if you're finding the distance between A and B, so remember, if you have 2 points, A and B, without any kind of symbols written over the top, it represents the distance from one of those points to the other. So this represents distance AB. And that's going to be the absolute value of the difference of their coordinates. Now remember, we talked about the coordinate of A and B being represented by the lowercase. So this is the distance, or the difference between A and B, or the absolute value of the difference between B and A. It doesn't matter which one you put first. If both numbers happen to be negative numbers, the distance is always going to be a non-negative value. Okay? So that's why you just take the absolute value of their difference. You can also count them if you want, but once you get to larger numbers that aren't on like a ruler that you can physically see, it's harder to do the counting. So just using the formula is the easiest way to do that. All right, so try on your own here, just by what we talked about and this formula given right here. Okay. Now I have both. Again, it doesn't matter which coordinate you put first. It's going to be the same either way. See if you can find what the distance xp is in this first example based on the given equation. Remember, it is allowed for most problems, and I assume that this is one, that you can enter your answer as a calculation. Okay? So if you had this problem right here and your understanding is that it's the absolute value of the difference of these coordinates, it's possible for you to enter the calculation in the following way. Now, you can either from the drop down, so when you get problems that are calculated in nature, you're going to have a drop down menu that you will open up when you when you click on the answer field. So you can go in and you can physically select the symbol for absolute value. You can also type in ABS. Once you hit ABS, the second you type the S key, it turns into an absolute value symbol. Okay? And so it will put that in there. And then if you type in the expression negative 32 minus 34, this is the absolute value of the difference of those coordinates. So absolute value of negative 32 minus 34. You could have also done absolute value of 34 minus a negative 32. Both of those work. It doesn't matter which order you put these differences in, because the absolute value is going to take care of any negative signs. And so you could have written this as well. And either way, you're going to get the answer of either absolute value of negative 66 or absolute value of positive 66. In each case, your answer is going to be 66. So you can enter your answer as whatever your final answer is, right? So you can do the calculation either mentally on paper or on a calculator by hand. You can also go in and just enter your answer as a calculation directly in the answer fields. Okay. So you'll see, I mean, it should preview. If you start typing this right here next to your problem, you're going to see a little, just a number show up that says equal to, and then it'll give you the preview of what the decimal form of the answer is. All right, so this is one of the calculations in calculating distance. All right, the next slide here, if we move, has to do with this concept of congruence. Okay, so if two segments are congruent, congruent means equal in all respects. So that's just sort of the definition of congruence, is that they are equal in all respects. Congruence refers to physical elements or physical figures or elements. Okay? It's not numerical values. So the congruence symbol looks like this. It's an equal sign with this similarity symbol above it. Okay, so congruence means it's similar and equal. So it's more than just similar, it's also equal. Okay, and equal in all respects means that if you have two line segments, they're the exact same length. But if you have two triangles, that means every corresponding length is the same, the perimeters are the same, every corresponding angle is the same, the areas are the same. Everything about those two figures is exactly the same. That's congruence. They're equal in all respects. So if you're talking about two figures or two segments being congruent, segment AB is congruent to CD, looks like this. This is how you would represent congruence. Now, what congruence also corresponds to is that if figures or elements are congruent, then their measurements, which is part of the all, that they are all in all respects, they are equal, it means that their measurements are the same. So congruence of elements and the equality of their measures are connected in that way. They correspond. So if you were told that segment AB and segment CD are congruent, those physical elements are, then that means that their distances, which are represented by AB and CD, they're equal. The distances refer to a magnitude or a numerical value. And so magnitudes are equal, the physical elements are congruent. Okay? And so this holds true for segments, it holds true for angles, and again, any of the figures that are completed, like triangles and rectangles, as circles and squares and all that. All right, so what I want you to do is, based on that, I want you to look at this number line and determine which of these given segments here is congruent, which of them is equal in their measurements. And so you do need to kind of go through and test each of the possibilities, but see if you can check off those that are congruent to each other. Let's take a look at these lengths here. So if we look at NM, NM is a total length of what? From 2 to 5 is 3. And then we look at H to N, that's a total length of 4. So that one's not going to be congruent, right? Let's look at the next set, RA. So here, -4 to 3, if you were to calculate this, it's -4 minus 3, which is -7. Absolute value of that is 7. And AE, from A to E, 3 to -2, is a total length of 5. So again, not congruent. We'll look at the next one, FE. FE is a length of 3, right? -5 to -2. And EH is a length of 3. So there's a set of congruent segments. R to H is -4 to 1, which is a length of 5. MF is -5 to 2. That's a total length of 7, so not congruent. HN, we did that already up here. HN is 4. SR, from -4 to 0 is 4. So there's a congruent set of segments. FS, here, -5 to 0 is 5. ME, -2 to 2 is 4. Not congruent. And then finally, NE, from N to E is -2 to 5 is 7, versus R to A, -4 to -3 is also 7. And so counting those gives you a set of congruent segments. And so again, just using the counting principles or the calculation, absolute value of the difference of coordinates, and then comparing their lengths, you can find the congruent segments. All right, how many of you guys remember plotting points from algebra? Okay. When you plot points, remember the points are set where it's the x-coordinate and the y-coordinate. The x-coordinate is the horizontal coordinate. Okay, so this is your x-axis. The y-coordinate is the vertical coordinate along the vertical y-axis. And so if you're looking to plot point A right here, you're plotting it at -9 on the x and then -3 on the y. And so this is where point A would be located. Hey, what I want you to do is plot the remaining 3. So plot B, C, and D. And then I want you to compare the segments A, B, and CD and determine whether those are or are not congruent. So see if you can plot those, count the distance, and then compare those distances and see, are they congruent segments? So when you're looking at these, we plot the remaining points. So B is -2, -3. So here's point B, which gives us the distance AB. And then we plot C, which is -3, 1. So here's point C. And D is -3, -6. And so connect those. All right, so once we have our distances, we can then just count. From 1 to -6, that's a distance of 7. From 9 to -2, also a distance of 7. And so what we see right here is we have congruent segments. Now, when you guys do your homework assignment for this, it will be mixed up. So your version might be one congruent and one not. Somebody else's might be the not congruent first, or it might be 2 not congruents. Or again, it's going to mix up the variations of those. It won't always be the same thing. Okay? So make sure you look at the specifics of each question first. Right, the last concept from the 1.2 is this concept that's called segment addition postulate. The word postulate is again there. It means that it's a assumed truth with no formal proof, and it's a little bit more specific to geometry, often based on constructions. And so here what it's saying is that the sum of the parts is equal to the whole. Okay, and so the way that that's going to be expressed is it's going to be expressed as a formula. And the formula, when you look at this segment AC with the point B between, is to say that the distance A to B and B to C, the sum of those two parts is equal to the whole, which is the distance AC. So this right here is segment addition postulate. Now, segment addition postulate has an alternate form. The alternate form of it says that the part is equal to the whole minus the other part. You guys see how that could be created, right? The sum of the parts is equal to the whole. If you took one of those parts to isolate it, you would do so by subtracting the other part from the whole. And so you get this relationship here that if I wanted to isolate part AB, that part is equal to the whole AC minus the other part, BC. Okay, or notice if I wanted to isolate BC, the second part BC, the part is equal to the whole AC minus the other part beside BC is the first part AB. And so those are sort of the alternate forms of saying this same thing. Now, the majority of the time, it's mostly going to be the first one, the sum of the parts equals the whole. You can always derive the secondary part from that. Okay? But these are the 3 different forms that represent segment addition. Okay? Right, so if we look at this basic form first, and then I'm going to have you do some of the more challenging versions of this, or the ones that you'll maybe be a little more challenged. Okay, so if you look at this first example right below, okay, so if you want to find this distance, FK, okay, and you know that part BF is 25 and the whole thing BK is 68, what would you need to do to solve for that missing piece? Yep, Sam. Right, and so all you need to do here is to say that the part, FK, is equal to the whole, 68, minus the other part, 25. So notice that that can be your answer, right? Remember, you can enter answers as calculations. That's probably the easiest thing to do when you're entering your homework. It also allows me to see your work. And so this is, I mentioned before, that this is how you show your work in this class. If you enter an answer as a calculation, when you do that, it will put a little preview over here and say 43. Okay, but entering the calculation is a nice, easy way to do that. Now that was solved with a mental calculation, right? If you set it up, you would say either the part plus the other part, sum of the parts is equal to the whole, and then solve, and that gives you your answer. Or you're going to say that the part FK is equal to the whole minus the other part. You can go directly to that sort of alternate definition for it and get your answer. And either way, it should lead to the correct solution. All right, so that's the easier form of using and solving segment addition. I want you to try this top question up here. Now, see if you can do the same thing when it's representing expressions. And so now, in order to find NQ, not only do you have to solve for x, you then have to plug x in and calculate what NQ is. So use segment addition to solve for x, then plug x in and identify what the NQ value is. So see if you can answer that question, please. Okay, so notice here's the most generic form of segment addition. The sum of the parts, NB plus BQ, is equal to NQ. Now, you don't necessarily need to write this down, right? I'm only doing it to explain exactly where everything comes from. Okay, but if you then plug in the expressions for each of these, so NB can be replaced by the expression 4x plus 11, BQ can be replaced by the expression 33, and NQ can be replaced by the expression 9x. Once you do that, it now just becomes a solving equation, and this is what the SAT version is like. SAT, you're solving, or on the 1.2 SAT or the Algebra 2 or the Algebra review, is going to solve equations like this with a single variable. So if you isolate your variable, move all the variables to one side, combine your like terms here, so you get 44 here is equal to 5. X, divide by 5 to isolate your x completely. So there is your value for x. Okay, 44 over 5 is not the answer to this question. This is just the value of x. What you then need to do is plug it into the expression for NQ. So NQ is 9 times 44 over 5. If you enter your answer as a calculation just like this, it will give you the decimal equivalent over here. Again, the decimal equivalent is 79.2. So you could have entered that as well. Okay, but entering the calculation is fine. All right, questions on that process of using segment addition to find the sum of the parts and the whole? All right, see if you can use that. And again, this is a little bit more complicated question, but see if you can figure out what would be the length of each of those given segments if all you know is that AD is 32. So I'll fill that in for you. AD is 32. And then use the information provided and see if you can find the remaining pieces. Okay, one of the ways to show congruence is to use tick marks in your diagrams. And so what that means is if you're given this relationship right here, AB and BC are congruent. What that means is that I can use tick marks to show that. So I use a single mark for each. That indicates that AB and BC are equal, congruent to each other. Okay. I then see that AC and CD are equal. So now I know that AC and CD are equal. Okay, and so for this, it doesn't, this one, again, there's really not a way to set the markings on it. Okay, but I am labeling them with those green kind of brackets or braces to show that those are the same. And then I know that that AD is 32. Well, if these two regions are the same and the whole thing is 32, what does that mean each one has to be? Half of 32, which is 16. So each of these is 16. And then if A to C is 16, what does that mean each of AB and BC have to be? 8 and 8. And so now you can fill in and get your measurements, right? So AB is 8, AC is 2/8 or 16, BC is 8, BD is 16 plus 8, right? 8 plus that 16. When you build up, BD is equal to BC plus CD. So you can either put that or you can draw or write in the whole measure, which is 24. And finally, CD is that length, 16. And so you can find those by using tick marks or, again, color coding your segments to indicate congruence and which ones are the same.